Hello everyone, in this video we'll be solving problem 83, remove duplicates from sorted list. The problem statement is, given the head of the sorted linked list, delete all duplicates such that each element appears only once. Return the linked list. Looking at example number 1, the input is 1, 1 and 2. Because we have two nodes with value 1, we need to eliminate 1. The output should be 1 and 2. Similarly, in example number 2, we have 1, 1, 2, 3, 3. So there are two duplicates, 1 and 3. So if we eliminate and make it unique, the output should be 1, 2 and 3. The constraints that are given to us is the total number of nodes in the list is in the range of 0 to 300. The value could be from negative 100 to positive 100 and it is guaranteed to be sorted. This is an easy problem and I'm positive that you will feel the same after we walk through the explanation. Let's switch to whiteboard and talk about the solution. Let's talk about a simple approach where we start the iteration from the start and build a new output list node with all unique values. We'll start by pointing at the first node in the input. Because it is the first node, it is bound to be unique. So we'll add its corresponding value or we'll add the node to our output. And then look at the next node. Now is this value equal to the previous value that is saved in the output node? Yes. So we will not add this to our output node. And look at the next node, which is 2. We'll do the same thing. Is its value equal to the last node in the output? No. So we will add it as a next node. Just like before, we'll increment our pointer and look at the next node, which is 3. Compare it against the last node. Is that equal? No. So we will add it as a next node. Again, looking at the next node in the input, which is 3, compare it with the last node in the output. They both are equal, so we'll do nothing. Once we are done with all the iterations, we'll have our output in this output variable, which we can return. The time complexity of this solution is O of n, as we are iterating through all of the nodes once. And the space complexity is O of n, as we are building this output array, and the worst case scenario could be all the nodes in the input are unique. As an improvement to the current solution, let's think about how we can avoid creating this output variable. So instead of creating an output variable to maintain all the unique nodes, what we can do is we can use the existing input node and remove all duplicates as we are iterating. Let me explain this by an example. So let's begin the iteration starting with the first node in the list node. We'll first check if the node.value is it equal to node.dex.value, considering there is a next node. So there are two possibilities. One is yes, other being no. If this condition is satisfied, meaning this node value is equal to the next node. So we need to eliminate this node. Next pointer should be pointing at this node's next, which is 2. So if this is removed, automatically we'll get this as the new set. So in terms of programming, node.next, which is this node's next, will become node.next.next, which will be number 2. And then we'll continue the loop. If the condition do not match, for example, after we remove this one node between 1 and 2, we'll do the check again, where we'll see if this node, the first node, is it equal to the next node. So the condition is not satisfied. So we'll increment our pointer. So my node will be node.next, and then we'll resume the iteration. So the next time we are comparing 2 and 3. Again, we'll check the corresponding value. They are not equal. So we'll go into the no side of this check and increment our pointer. So now we are looking at node 3. So this time we are looking at node 3 and its next value or next node is 3, which are equal. So we'll go inside the yes node and do the replacement. Because the next node of 3 is null, so the next node for the parent or the unique 3 node will also be null, and that's where we'll conclude our iteration, and this will be our output. With this approach, our time complexity remains the same, that is O of n, where n is the number of nodes in the list node, and the space complexity is improved to O of 1 as we are updating the input list node itself without creating a new variable. I hope you were able to understand this explanation. Let me show you how we can implement it using C#. So here is my C# solution. I start by checking if the head is not null. If it is, then we don't need to iterate and simply return it. My first check after that is to see if the head dot value is equals to head dot next dot value. So comparing the current node with the next node, if the values are equal, then I'm calling the same method again but passing the next node. This is where we replace the next node with the one after that. In case the if condition is not met, then I am incrementing my pointer. So now I'm looking at head.next by calling the delete.duplicate and by passing the next node. As you can see, this approach beats 100% of the solution made on LeetCode so far in terms of time complexity and almost 59% of the submissions in terms of memory consumption. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the solution is available in the description below. Feel free to check that out. If you have any questions, do not hesitate in reaching out to me, and I will see you in the next one. Thank you.